All right, so let's try to summarize what we've learned in this particular section. So first of all, we saw the concurrent collections. We saw that generally they have the try, take, try, pop, these kinds of methods, and typically those methods return a boolean indicating whether you have in fact succeeded. As you may guess, these collections are for the most part optimized for multi-threaded use, which means they try to do things as quickly as possible, sometimes by keeping, for example, several different thread local lists instead of just one list with shared access. And that's all done for purposes of performance. But you have to keep in mind that some operations, like for example getting the count of all the elements in the collection, that can actually block all other operations in the collection, and that can make the collection slow. So you have to be careful with those types of operations. But typically adding elements and taking out elements is reasonably fast, and you should be okay to do it generally. So that's that, and apart from that, we looked at ConcurrentBag, ConcurrentQ, and ConcurrentStack, and we saw the fact that they all implement this curious interface called iProducer-Consumer collection, which you can subsequently use for the producer-consumer pattern together with the blocking collection. So we saw blocking collection as this wrapper around any of these collections, and the idea was to provide bounding, so you can, for example, limit the number of elements that sit in the collection, and it subsequently provides blocking. So if you try to, for example, take out an element while the collection is empty, or to add an element while exceeding the bounds, then you effectively block the thread that's actually attempting to do this, and thereby you're sort of satisfying all the prerequisites of the producer-consumer